Hello, today we are looking at writing linear models and we are looking at data from the opioid crisis here in Pennsylvania. So in 2010, PA had 629 opioid overdose deaths. Over the next several years, the number of opioid overdose deaths increased by about 116 deaths each year. Our goal was to write a y equals mx plus b equation that would estimate the number of opioid overdose deaths in PA since 2010. So first off, we have to understand a little bit about this equation. The b in algebra class we usually learned is the y-intercept, and when we apply that to real life, we have that as the start. So in an algebra class that is on the y-axis, but when we're looking at real life, that's really about when time is 0 and what is the starting amount. We also have to recognize that from algebra class m was the slope, but in real life we call that to be the rate of change. And then the x and y will remain as variables. So when I go to write this equation, I have up here in 2010, there were 629 opioid deaths. Sorry, my pen went a little crazy there. And so that is the starting number that I know I can work with. And then I also have that there were 116 deaths per each year. So that is a rate of change because of that each year. That is how much it's changing. So when I go to write my equation, I'm writing y equals 116, because that's how much it's changing, so that's my slope, x plus that starting amount of 629. And so that gives me a y equals mx plus b model. In this model, I'm taking my rate of change, 116 per year, and that x would represent the years since 2010, the starting amount. And then my y, what this would calculate, this would calculate the overdose deaths. So let's see what other questions we have related to this example. So our next question is to use the equation to estimate the opioid overdose deaths in 2012. So 2012 is 2 years after 2010. And so when I look back at my equation, my x stood for the years, and so when I go to do this problem, I'm going to have y equals 116 times 2, because this is 2 years later, plus that starting amount of 629. And so I go to my calculator, type all of that into my calculator, and I get that this equals 861 deaths. So my equation would predict that 2012 had 861 opioid overdose deaths here in PA. The actual number was 827, so that's really nice that it was a little bit less, but it's not a ton less. So our equation gives, I think, a fairly reasonable estimate. If you subtract those two numbers, our equation was off by 34, which is about 4%, so it was not perfect, but it was not horrific. So our next equation asks us, in what year does your equation predict that the number of deaths will be greater than 1,000? So this time the 1,000 in this question, this would be a y value because up here at the beginning we said y represents the overdose deaths. So what I want to do is I want to put this into my original formula where the y is. So 1,000 equals 116x plus 629. And then I have just a little bit of algebra to do in order to solve this out. So I would want to subtract 629 from both sides, so minus 629 to move that over. and that would give me 371 equals 116x. And then to finish solving, I divide by 116 on both sides, and that will give me x equal to 3.198. So I have to think about this. This means 3 years after 2010. So if I take 2010 and I add to that the 3.19, so that would give me 2013.19, which means it does not happen in 2013, but it would happen after 2013, so we would guess 2014. And so we could answer or in 2014. So again, this is historical, so let's look at what happened. Sorry, this went right over my writing there. In 2014, we had 1,092 deaths, and that was the first year that more than 1,000 people had died of an opioid overdose. So our equation actually did a great job of predicting when that would happen because we had it starting a little bit after 2013 or in the year 2014. So our next equation says use your equation to estimate the opioid overdose deaths in 2016. So 2016 is 6 years later, and I'm getting that because our original model was years after 2010. So this is similar to what we did before. We'll write y equals 116, and then our x value is the 6 years later plus that original 629. I put all of that in my calculator, and it estimated 1,325. And again, this is historical, so we can take a look at what were the actual numbers and is our equation even useful or helpful. So the actual number of deaths was 2,235. So this time we are off by a lot. Did that subtraction and we are off by 910. So that's a huge amount. It's like 41%. So I think that's a terrible estimate. And then we're asked here, do you think that your equation would be good at predicting the opioid overdose deaths for 2019? And I would say no. It was not good at predicting 2016, so I don't see that this would still be valid for 2019. When we look at this scenario, at the beginning here back in 2010, the data was very linear, and so that's why we got a decent estimate in 2012, a great prediction for 2014, and then we've had what we call an opioid crisis, and the data has deviated from linear. So this gets a little bit theoretical, but I feel like let's go there and let's talk about it. So at the beginning, so back at 2010, we have data that if we were graphing it on an x and y axis, as the time goes out here, the deaths go up and it goes up linear. And the slope of that line is this 116 each year. What we have happening, and then at some point past 2014, because already by estimating 2016 we're off. So our prediction line, I'm going to put here, is that straight line, and then let me get a different color pen, because our actuality and why we consider this to be a crisis is that it did not continue as linear data. So we were linear all in here, and then we started curving up like that. And so this is actually what we consider an exponential model, where that slope gets steeper and steeper, and it increases by more and more. And so this red line in anything that is considered a crisis because it's growing exponentially as opposed to linearly.